All right, we're going to look at the domain and range of parent functions. So we got 6 here, a whole bunch of them. So we'll quickly jump over to this page here, and this page, I've already talked about the quadratic. I'm going to make the assumption you already know it. I'll quickly repeat it here that because it's continuous, so because it's a curved line or a straight line and not just coordinates, it's something that's drawn all together. We use x as the element of all real numbers, and nothing stops it left and right, so we just leave it at that. There's no restrictions. The y value, however, has a low point, the low point being this coordinate here, 0. And the range goes up forever but never passes this low point, so we say YER, again, because it's continuous, y is greater than 0. So that's pretty important. That gives us our range for the function. So if we were to write it over here, it'd be written like this. We say the domain for this is XER, and the range is YER, such that y is greater than or equal to 0. So there's our domain and range for our quadratic. Okay. The next function is called a reciprocal function. So let's get rid of what we wrote here. And the reciprocal function, we'll turn the quadratic off, looks like this. A reciprocal function gets extremely close to a vertical asymptote here. So it never really touches that. And a horizontal asymptote, I'll do my best to draw it, roughly about here. Okay, so it gets really, really close to this value, never quite touches, turns downwards, and gets really, really close to the y-axis without touching. And then to the right of 0, same idea, very close to the y-axis, turns very close to the x-axis. In terms of domain and range, well, it's continuous, right? So our domain is x is the element of all real numbers, but there is a restriction. As we come across, remember, we don't touch this middle part here, right? So x is the element of all real numbers such that x cannot equal 0. Okay? For our reciprocal function, that's going to be our domain. Our range. Well, the range is, again, it's continuous, so we start with y is the element of all real numbers such that, and in terms of y, remember, when y is equal to 0, it also doesn't touch that horizontal asymptote, so y cannot equal 0. So this is the domain and range for our reciprocal function, so we'll kind of quickly draw them in here. XER, such that x can't not be 0, and YER, such that y cannot be 0. Okay? This is a root function. This one's a little special. We'll go over again and erase what we had here. So we turn off our reciprocal root function. Now, if you notice, it kind of looks like a sideways parabola. If I was to kind of draw the rest of it in, wrong button. If I was to draw the rest of it in, there you go, like down here.
Oh, it's like half of a parabola.
Yeah, it looks like it. Now the reason it's a half because of the vertical line test. In order for something to be a function, I have to be able to draw a vertical line, and it can only touch it once, right?
Yeah.
So if it touched it down here, then it's no longer a function. So that's why it is only drawing the part on top. So that is still a function. So we have a root function. And if you notice, it starts at 0 and then heads to the right. The reason being is because we can't square root negative values. They're just undefined. We can't do it. Okay, so it doesn't exist below there. But to the right, it's continuous. So our domain, XER, such that x must be, and if we take a look, it's equal to 0 because we can take the square root of 0. Square root of 0 is 0. So x is greater than and equal to the value of 0. And that's it. So what that's saying is this exists everywhere to the right of 0, but nowhere to the left. And in terms of the range. Now, the range is finicky. The reason being, as you can see, the range is continuous. It goes upwards, so y is greater than and equal to 0. The only side note to this is technically if I were to draw this in here, right? If it wasn't a function, then it would just be YER because it goes up and down forever. But because we're making it a function, we can't draw this bottom part in, so we have to give it the parameter that it has to be greater than 0. Okay, so we just have to keep that in mind.
All right.
So our domain and range for this guy here, XER, x greater than or equal to 0, yer y is greater than or equal to 0. Next function is called a cubic function. Let's get rid of what we have. Okay. Cubic function is, turn on please, there you go. Funny looking function. Okay. In racing, they call this a chicane. A chicane is where you do like an S-turn or whatever. So it's continuous. So in terms of domain, XER, there's no restriction to it. It's going to go forever. Okay, it's going to go all the way to the right and all the way to the left. Even though it kind of looks like there might be some kind of vertical asymptotes on both sides, it's not the case. It's going to go left and right forever. And the range actually in this one is the same. It's also going to go up and down forever. And that one might look a little more obvious by the way it's like traveling upwards and traveling downwards. But the domain and range is just everything. It will touch every single point there is on a graph. Okay, so that one's a lot easier. The only thing is it just looks a little funny.
Yeah.
Okay, and we'll talk a little more about cubic functions after. So for this one here, I haven't done green yet, XER and YER, and that's it for that one there. Okay, the next function is a take on a circle function. And they've written it this way so that it will be a function. So I'll kind of talk about it over here. Let's get rid of our old stuff.
Oh, because if it goes past 0, it's not a function.
That's right. If it was a full circle, I'll turn it off here. So you'll notice they're only drawing a semicircle here, right? And the reason they're only drawing a semicircle is, again, because of our vertical line test. It's got to pass through. If they were to draw the whole circle, it wouldn't pass the vertical line test, and it wouldn't be a circle. And usually in grade 9, sometimes in grade 10, they give you a function of a circle. It's written as r squared. That's the radius. So in this one, the center's at 0. So the radius to the outside would be r, is equal to x squared plus y squared. So this is usually a circle function.
Yeah.
But when we write functions, we try to set things equal to y. Okay, so what they've done is they've moved the x squared over. So you have r squared minus x squared is equal to y squared. So I'm just kind of working through the algebra. Then we bring over the square root. So the square root of r squared minus x squared is equal to y.
Oh, and then the...
Okay. And if you look, that's pretty similar to what we got here, right? Our radius is actually from 0 to 4, right? Because the root of 16 is 4. So root 16 equals 4. That makes sense for the radius to be 4. Technically, it should be plus or minus, but in order to make it a function, we don't do the minus part because it has to pass that vertical line test. Okay? So, now that we know this is generally a circle, this one's a little different. It is continuous, so our domain is XER. But there's parameters. Think of it like it can only go so far to the left and so far to the right. So x is greater than or equal to the lowest value on the left, which is negative 4. And it is less than or equal to the highest value on the right, which is positive 4. So that's your set notation for the circle. For our range, again, it's continuous, so YER. The difference here is because I only drew the bottom part in, the lowest value for our y has to be 0. So we say y is greater than or equal to 0 and less than or equal to the highest value, which is 4 here. If we were doing a true circle, like the original function I gave you, the lowest value would technically be negative 4, but then it wouldn't be a function. So for us to turn it into a function, it changes what its range would be. Okay? So this one's a little more complex because it has parameters on both the left, the right, the top, and the bottom. So we go to write that in here. XER, negative 4 was the lowest, and positive 4 was the highest. And then YER, the lowest had to be 0 in order to be a function, and the highest again was 4 in that case. Okay, the last function here is called an absolute function, or the absolute value of something. So let's erase what we had. Okay, let's turn off the circle. Absolute. Okay, so this one is an odd-looking function. The absolute value deals with the idea of no matter what I put between these brackets, so negative 5 is equal to 5. Positive 5 is also equal to positive 5. So we're talking about the absolute value. Whatever the unit's value is, that's what the y value is, regardless if it's positive or negative. So in other words, you kind of get a linear function in a positive way on the right, and you have a linear function coming down to the origin on the left. It's like a giant V. Okay, it is continuous. So for our domain, we have x, e, r, and there's nothing really stopping it, so that's all there is to it. Again, the y value is continuous, so y, e, r, but there is a restriction. The restriction here is we never go into the negatives of the y value, so y has to be greater than and equal to the value of 0 in that case. And then that's it. So we'll kind of write that one in. Use another color. This is XER, and then YER, such that y is greater than and equal to 0. And that is all of your domain range for the parent function.